Bismillahirrahmanirrahim. Assalamu alaikum. We shall study about the indeterminate forms and the L'Hopital rule. These 7 forms are called the indeterminate form. To evaluate the limits of functions, sometimes we get 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 0 power 0, infinity power 0, or 1 power infinity. So if we get any of these forms, it will mean that this is not the final solution. We still need to do some more work to determine the final answer. Let us see the L'Hopital rule, which says that if limit x approaches to a, f of x over g of x is 0 by 0, which means that the limits of function f of x at x is equal to a is 0, and the limits of g of x at x is equal to a is 0. So we get 0 by 0 form. Then according to this rule, this limits will be equal to limit x approaches to a, f dash of x over g dash of x. And if we replace x by a, we get f dash of a divided by g dash of a. So in simple words, we shall differentiate the function in numerator, and we shall also differentiate the function in the denominator, and then we can apply the limits. This rule is used only if we have 0 by 0 form or infinity by infinity form. So if we have any of these two cases, we can use this rule. We can use the L'Hopital rule only if we have 0 by 0 form or infinity by infinity form. In that case, if limit x approaches to a, f of x over g of x is 0 by 0 or infinity by infinity, then we shall differentiate the function in numerator, and the function we will also differentiate the function in the denominator. Then plug in the limit x is equal to a in f dash and g dash. If we don't get 0 by 0 or infinity by infinity, in other words, if we get any real number or only infinity or only minus infinity, then that will be the solution, and that's all. But if again we get 0 by 0 form or infinity by infinity form, then we shall differentiate f dash once again and g dash once again. And then we shall plug in the limit x is equal to a in f double dash and g double dash. If the solution is not 0 by 0 or infinity by infinity, then that is the required solution, and that's all. But if again we get 0 by 0 form or infinity by infinity form, then we have to differentiate f double dash once again, and we have to differentiate g double dash once again. Now again plug in the value x is equal to a in f double dash, f triple dash, and in g triple dash. If we don't get 0 by 0 or infinity by infinity form, then that is the required solution, and that's all. But if again we get 0 by 0 form or infinity by infinity form, so the process will continue. In example number 1, we are using the L'Hopital rule to find the limits. Let L is equal to limit x approaches to 0 sine x over x. Now if we plug in x is equal to 0, we can see this is 0 by 0 form. Therefore, by using the L'Hopital rule, we can obtain L is equal to limit x approaches to 0 d by dx of sine x divided by d by dx of x. From this we can find limit x approaches to 0 cos x divided by 1. And now if we apply the limits, we get cos 0. And the value of cos 0 is 1. Hence, limit x approaches to 0 sine x over x is equal to 1. That is the required solution. Now let us find the limits in example number 2. Here again, for simplicity, we let L is equal to limit x approaches to 0 to cos x minus 2 plus x square divided by x4. And now we can see that if we plug in x is equal to 0, we get 0 by 0 form. Therefore, we use the L'Hopital rule. According to the L'Hopital rule, we have L is equal to limit x approaches to 0, differentiation of cos is minus sine. So we have minus 2 sine x, differentiation of 2 is 0, differentiation of x square is 2x, divided by differentiation of x4 is 4x cube. Now if we put x is equal to 0, again we have 0 by 0 form. So we use the L'Hopital rule again. Then we can write L is equal to limit x approaches to 0. Differentiation of sine, that is cos, differentiation of 2x is 2, and differentiation of 4x cube, that is 12x square. And again, if I plug in x is equal to 0, we get 0 by 0 form. So let us again apply the L'Hopital rule. So according to the L'Hopital rule, we have limit x approaches to 0. And differentiation of cos is minus sine, so we can write 2 sine x divided by 24x. If we use the limits, again we have 0 by 0 form. So again we apply the L'Hopital rule. So L is equal to limit x approaches to 0 to cos x divided by 24. And now if we apply the limits, we have 2 over 24. So we can write limit x approaches to 0 to cos x minus 2 plus x square divided by x power 4 is equal to 1 over 12. To solve example number 3, we let L is equal to limit x approaches to infinity, x cube divided by e power x. And now if we use the limits, we can see this is infinity by infinity form. Therefore, we use the L'Hopital rule. So L is equal to limit x approaches to infinity d by dx of x cube divided by d by dx of e power x. And from this we can obtain limit x approaches to infinity 3x square divided by e power x. Again we can see that if we apply the limits, we have infinity by infinity form. Therefore, we use the L'Hopital rule once again. So according to this rule, let us differentiate the function in numerator. So we have 6x divided by, let us differentiate the function in the denominator. And again, plug in the limits, we have infinity by infinity form. So we again apply the L'Hopital rule. So L is equal to limit x approaches to infinity 6 divided by e power x. And now if we plug in the limits, we have 6 over e power infinity is infinity. So we have 0. Therefore, limit x approaches to infinity, x cube divided by e power x is equal to 0, and that is the required solution. Let us consider case number 3. If we have infinity minus infinity form, in that case we shall take the LCM and simplify the question, and it will automatically be reduced to the 0 by 0 form or infinity by infinity form. Let us solve example number 4. In this example, let L is equal to limit x approaches to 1 over x minus 1 minus 1 over ln x. If we plug in x is equal to 1, we can see we can get infinity minus infinity form. Log 1 is 0. So we take the LCM. Let us take the LCM. We have limit x approaches to 1, and now the LCM is x minus 1 into ln x. So we have ln x here and minus x minus 1 here. Now if we plug in x is equal to 1, we can see this is 0 by 0 form. So we can use the L'Hopital rule. By the L'Hopital rule, we have limit x approaches to 1. Let us differentiate the function in the numerator. And here we have minus 1 divided by, we will apply the product rule. First, differentiation of the second plus second differentiation of the first, which is 1. Now let us take the LCM and simplify these two terms. So we have limit x approaches to 1. From the above we have 1 minus x divided by x whole divided by, from here we have x minus 1 plus x ln x whole divided by x. And now we can see this x will cancel with this x, and we can get limit x approaches to 1 minus x divided by x minus 1 plus x ln x. Now again plug in x is equal to 1. So we have 0 by 0 form again. We are using the L'Hopital rule once again. So we have limit x approaches to 1 minus 1 divided by 1 plus first function differentiation of the second plus second function differentiation of the first. From this we obtain limit x approaches to 1 minus 1 divided by 1 plus 1 plus ln x. Let us apply the limits. So we have minus 1 over 1 plus 1 plus ln 0, ln 1 is 0. So we have minus 1 over 2. So that is the final solution. If we have case number 4, 0 into infinity form, we shall simplify the question in such a way to form 0 by 0 form or infinity by infinity form. Let us see it by solving example number 5. Here we have limit x approaches to 0, x into ln x. If we plug in x is equal to 0, we can get 0 into infinity form because log 0 is infinity. So let us simplify this in such a way to get 0 by 0 form or infinity by infinity form. Let us write log x as it is and bring x to the denominator. So it will become 1 over x. Now if we plug in x is equal to 0, we get infinity by infinity form. So now we can use the L'Hopital rule. So according to the L'Hopital rule, we have to differentiate the function in numerator. The function in numerator is log x, differentiation of log x is 1 over x. And we have to differentiate the function in the denominator. So differentiation of 1 over x is minus 1 over x square. Let us simplify this. So we have limit x approaches to 0, 1 over x into minus x square by 1. And from this we can get limit x approaches to 0 minus x. Hence we get that limit x approaches to 0, x into ln x is equal to, if we plug in x is equal to 0, we get 0, and that is the required solution. The method for the solution of case number 5, 6 and 7 is same. So let us solve example number 6 to learn the method. The first step is we have to let y is equal to the function given in the question, which is x power x. In the next step, we take log on both sides. So now we can use the rule of logarithm. According to that rule, we write x ln x. Let us write the rule here. Log m power n is equal to n log m. And now let us take limits on both sides. So we have limit x approaches to 0, ln y is equal to limit x approaches to 0, x into ln x. Now if we plug in x is equal to 0, we can see that this is 0 into infinity form. So just like in the previous question, we need to convert this into 0 by 0 form or infinity by infinity form. So we write this like log x over 1 over x. And now we can see this is infinity by infinity form. So we can use the L'Hopital rule. So according to the L'Hopital rule, now we can write limit x approaches to 0, ln y is equal to limit x approaches to 0. Differentiation of log x is 1 over x and differentiation of 1 over x is minus 1 over x square. And if we simplify this, we get minus x. If we plug in x is equal to 0, we have 0. So limit x approaches to 0, ln y is equal to 0. In the next step, we write it as limit x approaches to 0, e power ln y is equal to e power 0. Now ln and e will cancel. So we have limit x approaches to 0, y is equal to e power 0. And now we can see from 1, let us say this is 1. From 1, we can use the value of y. So we have limit x approaches to 0. The value of y is x power x. And e power 0 is 1. And that is the required solution. To solve example number 7, we can see that this is infinity power 0 form because 1 divided by infinity is 0. So just like in the previous example, we let y is equal to x power 1 over x. And now just take log on both sides. So we have ln y is equal to ln x power 1 over x. According to the rules of logarithm, we can write ln y is equal to 1 over x into ln x. And now let us take limits on both sides. So if we take limits, x approaches to infinity, ln y is equal to limit x approaches to infinity, ln x divided by x. And if we plug in x is equal to infinity, we can see this is infinity by infinity form because log infinity is infinity. So we can use the L'Hopital rule. According to the L'Hopital rule, we can write limit x approaches to infinity, ln y is equal to limit x approaches to infinity, differentiation of log x is 1 over x and differentiation of x is 1. So now if we plug in the limits, 1 divided by infinity is 0. So in the next step, we can write both sides into the power of e. So we can write limit x approaches to infinity, e power ln y is equal to e power 0. Now log and e will cancel. So we can get limit x approaches to infinity, y is equal to e power 0. Now look at the value of y. So just put the value of y, we can write x power 1 over x and e power 0 is 1. So that is the required solution. If we put x is equal to 0, we can see that this is 1 power infinity form because 1 divided by 0 is infinity. So just like in the previous question, we let y is equal to 1 plus x whole power 1 over x. Let us say this is 1. And now let us take log on both sides. So we have log y is equal to log of 1 plus x whole power 1 over x. Now, by the rules of logarithm, we can write this 1 over x into log of 1 plus x. And now let us take limits on both sides. So we have log y is equal to limit x approaches to 0 log of 1 plus x divided by x. And now if we plug in x is equal to 0, we get 0 by 0 form. So we can use the L'Hopital rule. So according to the L'Hopital rule, we can write limit x approaches to 0. Differentiation of log of 1 plus x. This is 1 over 1 plus x. Divided by differentiation of x, that is 1. So from here we get limit x approaches to 0, ln y is equal to limit x approaches to 0, 1 over 1 plus x. And from this we get 1 if we plug in x is equal to 0. In the next step, let us write both sides into the power of e. So we can write e power ln y is equal to e power 1. Ln will cancel with e and we can get limit x approaches to 0, y is equal to e. Now what is y? Look at 1. From 1 we can write the value of y, which is 1 plus x whole power 1 over x. And this is equal to e. So that is the required solution. That's all.